The B-17 Flying Fortress was not simply an aircraft. It was a belief turned into aluminum, engines, and firepower. Designed in the years before the Second World War, the B-17 was born from a radical idea that a bomber could defend itself, survive enemy attacks, and strike deep into hostile territory in broad daylight. At a time when air power doctrine was still evolving, the United States Army Air Corps placed its faith in altitude, formation, and overwhelming defensive guns. First flown in 1935, the B-17 was a four-engine heavy bomber built for range, height, and endurance. Early models exposed weaknesses, but rapid wartime development transformed the aircraft into a flying fortress in every sense of the word. By the time later variants entered combat, the bomber carried up to 13.50 caliber machine guns, covering nearly every angle of attack. The strategy was simple in theory. Tight formations of bombers would protect one another, allowing them to fight their way to their targets without relying entirely on escorts. Inside the aircraft, the scale was imposing. With a wingspan of over 100 feet and a maximum weight exceeding 65,000 pounds, the B-17 was a giant of its era. Powered by four Wright Cyclone radial engines, it could cruise above 25,000 feet, where thin air and freezing temperatures tested both machines and men. Every component was built with redundancy in mind. Control cables were doubled. Systems were designed to function even after sustaining damage. Survival was engineered into the aircraft. The B-17 entered combat over Europe in 1942, joining a brutal air war already underway. American doctrine emphasized daylight precision bombing, targeting factories, rail yards, oil refineries, and aircraft plants. Unlike the British night bombing campaign, U.S. planners believed accuracy would break Germany's industrial backbone. But reality arrived quickly and violently. German fighters attacked relentlessly, and anti-aircraft flak filled the skies with steel fragments capable of shredding aircraft in seconds. The bomber's true test came not from its design, but from what it endured. Aircraft returned with massive sections missing, engines destroyed, and control surfaces barely intact. Yet many still flew home. Crews began to trust the fortress not because it was invincible, but because it gave them a fighting chance. Inside the unpressurized fuselage, 10 crewmen operated in constant cold, noise, and danger. Oxygen masks were essential. Frost formed on metal frames. Any mistake could be fatal. At the nose of the aircraft, the bombardier relied on the Norden bomb sight, a closely guarded technological secret. In ideal conditions, it promised unprecedented accuracy. In combat, turbulence, smoke, evasive maneuvers, and flak made precision far more difficult. Still, these daylight raids forced Germany to defend its skies continuously, diverting resources, aircraft, and pilots away from the front lines. As missions pushed deeper into Germany, losses escalated. Before long-range escorts became available, B-17 formations flew beyond fighter protection, leaving them exposed for hours. German pilots perfected head-on attacks, exploiting brief windows where defensive fire was weakest. Entire formations were decimated. Yet the campaign continued, driven by the belief that sustained pressure would wear the enemy down. That balance shifted with the arrival of long-range escort fighters, most notably the P-51 Mustang. With escorts capable of accompanying bombers all the way to Berlin and back, the air war changed dramatically. German fighter losses mounted, experienced pilots disappeared, and air superiority slowly tilted in the Allies' favor. Bomber streams grew larger, more frequent, and more devastating. By 1944, the cumulative impact of strategic bombing was impossible to ignore. German oil production collapsed. Rail networks were crippled. Aircraft manufacturing struggled to recover from repeated strikes. Though debates over effectiveness continue, the pressure exerted by B-17 formations reshaped the war.